Let's start with another chapter, that is electricity. So before we go in details on electricity, let's know what are charges. It has been found by experiment that there are two types of electric charge. Two types of electric charge. One is the positive charge, another one is the negative charge. How this charge are created when two bodies are rubbed against each other, when the two bodies rubbed against each other, a body that loses electron, they become positive charge, and the body which gain electron, they become negatively charged. So in this manner, the two types of charge are produced. When two bodies are rubbed against each other, the body which loses electron, that is electron being transferred from one body to another, the one which loses electron, they become positive charge, which gain electron, they become negative charge. Opposite charge. What are opposite charge or unlike charges? Opposite charges or unlike charges, they attract each other. Opposite charges or unlike charges, they attract each other. For example, when a positive charge it is brought near a negative charge, they attract each other. And what happen in case of similar charges or like charges? In case of similar charges or like charges, they repel one another. For example, when a positive charge is brought near another positive charge, they repel one another. Or a negative charge is brought near another negative charge, they repel. So this is the introductory portion of the charge. What is charge? Now let's come to the SI unit of charge. What is the SI unit of electric charge? SI unit of electric charge is coulomb. It is coulomb, which is denoted by capital letter C. This is coulomb. SI unit of charge is coulomb, which is denoted by a capital letter C. So 1 coulomb is the quantity of electric charge which exerts a force on an equal charge placed at a distance from it. That is 1 coulomb of charge. And what is the value of charge for electron? For electron, an electron possesses negative charge of 1.6 into 10 to the power of minus 19 coulomb, and proton also has same charge, but that is positive inside, 1.6 into 10 to the power of minus 19 coulomb. So an electron possesses a negative charge of minus 1.6 into 10 to the power of minus 19 coulomb. Okay. What are conductors and what are insulators? Conductors are those substances through which electricity can flow. Electricity can flow through them. Okay. For example, all metals like silver, there is copper, there is aluminium, they are all conductors. Even the metal alloys like the nichrome and manganese, they are also used for making heating elements of electrical appliances and are also conductors. Our human body is also a good conductor. Okay, and now what are insulators? Insulators are those substances through which electricity cannot flow. For example, there is a glass, there is ebonite, there is rubber, plastic, wood. These are all insulators through which electricity cannot pass. Okay, all the conductors like the metals, have some electron. They have got some electron which are loosely held. they have some electron which are loosely held by the nuclei of their atom. They are loosely held. We know that atom, it consists of proton and neutron. So there are certain metals which have some electrons which are loosely held by the nuclei of their atom, these loosely bound electrons, they are called free electrons. And these free electrons, they can move from one atom to another atom throughout the conductor. The presence of this free electron in a substance make it a conductor of electricity. Clear? So these loose electrons which are present in the metals, actually these loosely bounded electrons, they are the free electrons that can move from one place to another throughout the conductor, and the presence of this free electron in a substance make it a conductor of electricity. Now what happens in the case of insulator? I have already talked about conductor. What happens in the case of insulator that make the insulator a bad conductor of electricity? Actually, in case of insulator, the electrons which are present, the electrons that are present in the insulator, they are strongly held by nuclei. The nucleus, they strongly held them towards it. The electron present in the insulator are strongly held by the nuclei. They are strongly held by the nuclei of their atom. And since there is no free electron, in an insulator which can move from one atom to another, an insulator does not allow electric charge or electricity to flow through it. So this is the basic difference between a conductor and an insulator. In case of a conductor, there are free electrons which are present, which actually help in conductivity of electricity. But in case of insulator, there is no free electron. So as there is no free electrons, and the nuclei, they held them strongly, they held the electrons, the nuclei, they held the electrons strongly, that no free electron is present, which make the insulator bad conductor of electricity. Okay. Now this electricity can be categorized into two parts. One is static electricity, and another is current electricity. In this chapter we will be dealing with current electricity, but I will say something about the static part. Static electricity, I'll just give you some idea or glimpse about what is static electricity. So electricity can be classified into the static electricity and current electricity. This very chapter, it is much more about this current electricity. But what is static electricity? In static electricity, the electric charge, they remain stationary, or they remain at rest. The charge which gets created, the transfer of electron, we know that by rubbing the two substances, electrons get transferred. The one which gains electron, they become negative charge. The one which loses electron become positive charge. So this electric charge which are formed, they remain at rest, or they remain stationary, and they do not move. The charge, they remain stationary. There is no motion in the charge. That is what happens in case of static electricity. But what happens in case of current electricity? In current electricity, in current electricity, in current electricity, uh, there is a electric charges are in motion. Electric charges, they are in motion. They are in motion, and they produce an electric current. The electricity that we use in our home, in our appliances, it is all the electric charge which are in motion. So the electric charge, when they are stagnant or they are rest or they are at stationary position, we call them as static electricity. And when this charge they flow, when the charges flow, they create current electricity. Clear? Now let's come to the point, what is electric current? We'll learn this now in detail. Electric current. So when the two bodies, when the two charged bodies, which are at different electric potential, suppose this is at positive one and this one is in negative. When the two charged bodies at different electric potential, they are connected by a metal wire. When they are connected by a metal wire, then electric charge will flow from a body which is at higher potential to the body which is at lower potential, until and unless they gain, until and unless they both acquire same potential. Suppose this body is positively charged. Positively charged means it is at deficient of electron, deficiency of electron, deficiency, the deficient of electron, and this one has more electron. So unless and until both this body they acquire same potential of charge, the charge will continue to flow from high potential to low potential. When the two charged bodies are at different electric potential, that is one at a higher potential, another at a lower potential, and they are connected by a metal wire. Why a metal wire is connected? Because metal wire are good conductors of electricity. They can carry the flow of charge. So then electric charge will flow from a body which is at higher potential to the body which is at lower potential, and till what time or what point? Till they both acquire the same potential, unless and until the same potential is acquired, unless and until the same potential is acquired. This flow of charge in the metal wire, it constitutes electric current. So one thing is very clear, it is the potential. This is the potential difference. It is the potential difference between the ends of the wire, between the ends of the wire, which makes electric charge to flow, which makes electric charge to flow or current to flow. The potential difference is the reason why that is the reason why the electric charge or electric current is flowing, because the two bodies are at different potential, one at a very high potential, another at a low potential. Similarly, in case of biology, we know osmosis, when water molecules it flow from a higher potential to a lower potential, unless and until both are in the same state. In this case also the same thing happens. Unless and until both acquire the same potential, the electric current flows through the wire. Okay, the electric charge whose flow in a metal wire constitute electric current are the negative charge called electron, because we know electrons are the only one which can flow. Protons, they are stationary, they do not flow. Only electrons flow. So electric charge that is flowing through the metal wire, the wire constitute electric current, are the negative charge which are called electrons. Okay, so the electric current is nothing, it is a flow of electron. It is nothing but the flow of electrons in a conductor. It is a flow of electrons in a conductor through a metal wire. Through a metal wire. Through a metal wire. Okay. Now let's come the SI unit of electric current. The SI unit of electric current is ampere. It is ampere and it is denoted by capital E. Ampere. Okay. And let's say that if a charge of Q coulomb, there is a charge of coulomb, there is a charge of Q coulomb, it flows through a conductor. It flows through a conductor in time t. It flows through a conductor in time t. Then the magnitude of I, what will be the magnitude of I of electric current? I is equal to, this current is equal to charge, electric charge by time, Q by small t. I is equal to Q by small t. So, from here we can come to a conclusion. What is the meaning of 1 ampere current? 1 ampere current is when 1 coulomb of charge, it flows through a cross section of a conductor in 1 second. The electric current flowing through it is called 1 ampere. So 1 ampere is equal to 1 coulomb by 1 second. 1 ampere is equal to 1 coulomb by 1 second, or we can write 1 coulomb per second inverse. This is 1 ampere. So the definition of 1 ampere is when 1 coulomb of charge, it flows through a cross section of a conductor in 1 second. The electric current flowing through it is known as 1 ampere. Now let's come to the smaller unit of ampere. What is 1 milliampere? 1 milliampere. 1 milliampere is equal to 10 to the power of minus 3 ampere. 1 milliampere. And 1 microampere is equal to 10 to the power of minus 6 ampere. And this current, the current is measured by an instrument which is known as ammeter. So ammeter is the instrument which measures current. Now let's talk about the flow of current. Let's take a metal. Suppose this is a metal. Suppose a metal. And in this metal there are n number of electrons present. N number of electrons. N number of electrons which is present. If n number of electron, it pass through this cross section area of a conductor in time t. In time t. Then what will be the total charge? What will be the total charge? N number of electron is passing through a conductor in time t. What is the total charge? So in that case, Q is equal to small n into E. Here small n is the n number of electrons and E is the charge of each electron, which is 1.6 into 10 to the power of minus 19 coulomb. So the total charge flowing through the conductor is number of electrons, that is n number of electrons flowing, and charge of an electron. Q is equal to n into E. So we get a new formula of electric current. I is equal to Q by T, which is also equal to small n into E divided by T. This is another formula of current. I is equal to Q by T. If in any question Q, that is the charge, is not given and you are said that 50 electrons are flowing through a conductor, then what will be the current flow? So 50 electrons will have actual charge will be 50 into 1.6 into 10 to the power of minus 19 coulomb. This will be the charge. This will be the value of Q divided by the time which is given to you. That way Q by T will give you the amount of current flow. Now come to the concept of potential. What is potential? What is potential? Suppose this is point A, this is point B. Amount of work done in bringing a unit positive charge from infinity to that point. The work done in moving a charge from one place to another. The work which is done in moving the charge, that is called potential. And it is denoted by capital V, and it is a scalar quantity. It is a scalar quantity. If W joule of work is done, if W joule of work is done in bringing the charge Q coulomb from infinity to that point, then the electric potential, the formula will be V is equal to W by Q. What does this mean? That is, if W work done, that is if work of W joule of work done in bringing the charge Q coulomb from infinity to that point. So this will be V is equal to W by T. That is unit of potential V. Unit of potential V is equal to unit of work divided by unit of charge. That is joule coulomb inverse. Now, what is potential difference? What is the potential difference? Potential difference is between 2 points equal to the work done in bringing a unit positive charge from one point to another. Suppose this is point A, this is point B. Potential difference is, what is potential difference? VA minus VB is equal to W by Q. This is the potential difference. That is, it is between the 2 points which is equal to the work done. Work done in bringing a unit positive charge from one point to another. The work done in bringing the unit positive charge from one point to another, the difference between these 2 points is known as potential difference.